Mount Gambier looks harmless. From above, it's just a quiet volcanic hill rising gently from the plains of South Australia. A ring of green farmland surrounds it. The famous Blue Lake sits peacefully inside the crater. The town itself spreads calmly across the slopes, but directly beneath the streets, houses and parks, the ground is hollow. Hidden under this volcano is a maze of limestone caves. Some are dry chambers with cathedral-like ceilings, others plunge straight into deep, dark water, and many of them connect into flooded tunnels that stretch far beyond what anyone on the surface can see. Most people visiting Mount Gambier never realise it, but the ground beneath Australia's youngest volcano is riddled with voids. An underground landscape carved long before the volcano itself even existed. And understanding how those caves formed means rewinding the geological clock far beyond the volcano, back to a time when this entire region sat beneath a warm, tropical sea. To understand the caves beneath Mount Gambier, we have to start around 30 to 40 million years ago, during the late Eocene and Oligocene periods. At that time, southern Australia looked very different from today. Sea levels were higher, and the region around modern-day Mount Gambier was submerged beneath a shallow marine environment. This sea was warm, clear and biologically rich, the perfect conditions for limestone formation. Limestone is a sedimentary rock made primarily of calcium carbonate, which accumulates from the shells and skeletons of marine organisms like mollusks, corals and microscopic plankton. Over millions of years, enormous volumes of carbonate sediment settled on the seafloor. Layer after layer built up, slowly compacting into rock. The result was a thick limestone formation now known as the Gambier Limestone. This rock is extremely important to the story of the caves, because limestone behaves differently from most other rocks. Unlike granite or basalt, limestone dissolves relatively easily in slightly acidic water. That simple chemical property is what eventually hollowed out the landscape beneath Mount Gambier. The caves began forming after the sea retreated and the limestone was exposed to rainfall and groundwater. Rainwater might seem harmless, but it contains dissolved carbon dioxide from the atmosphere and soil. When carbon dioxide mixes with water, it forms a weak acid called carbonic acid. Carbonic acid is capable of dissolving calcium carbonate, the main component of limestone. Over long periods of time, rainwater seeped down through cracks and fractures in the rock. As the acidic water moved through the limestone, it slowly dissolved the rock along these pathways. This process is called karstification. Karstification is the chemical weathering of soluble rocks, particularly limestone, which leads to the formation of caves, sinkholes and underground drainage systems. At first, the fractures were tiny, barely large enough for water to pass through, but as the acidic water kept flowing, the cracks gradually widened. Over thousands, then millions of years, these narrow pathways grew into tunnels, chambers and underground rivers. Eventually, a complex network of caves formed beneath the limestone plateau. Many of the passages developed near the water table, the boundary between saturated rock below and air-filled rock above. The water table is essentially the level underground, where all pores and fractures are completely filled with water. When cave formation occurs along the water table, it often produces long, gently sloping tunnels rather than steep vertical shafts. This is exactly what we see in many of the caves around Mount Gambier. Mount Gambier itself is a relatively young volcano. It formed around 5,000 years ago during the most recent phase of volcanic activity in the newer Volcanics province. This volcanic province stretches across western Victoria and southeastern South Australia and contains hundreds of small basaltic volcanoes. The eruptions that built Mount Gambier were not massive mountain building events like those that formed Mount Fuji or Mount St. Helens. Instead, they were smaller, maar-style eruptions. A maar is a volcanic crater formed when rising magma interacts violently with groundwater. The intense heat flashes the water into steam, creating powerful explosions that excavate a crater. These explosions blasted through the existing limestone and left behind several volcanic craters, including the one now occupied by the Blue Lake. So by the time Mount Gambier erupted, the limestone beneath it was already riddled with caves. The volcano didn't create the caves, it simply erupted through them. Today, the cave systems beneath Mount Gambier are extensive, though their full size is still unknown. Several major caves have been explored and mapped, including Engelbrecht Cave, Tank Cave, and Little Blue Lake Cave. Many of these caves contain both dry passages and flooded tunnels. In fact, a large portion of the system is underwater. This is because the regional water table sits quite high within the limestone. The flooded caves are known as phreatic caves. A phreatic cave is one that forms completely below the water table, where the passages remain filled with water. Phreatic cave passages often have smooth, rounded shapes because the dissolving water flows evenly across the entire surface of the rock. If you look at cave survey maps from the area, you'll notice many passages are long and gently curving rather than jagged or vertical. That shape is a signature of phreatic cave formation. One of the most famous caves beneath the town is the Engelbrecht Cave. What makes it remarkable is its location. It sits directly beneath the urban centre of Mount Gambier. Visitors can descend into the cave through a sinkhole entrance, where a large chamber opens beneath the surface, but what can be accessed on foot is only part of the system. Beyond the dry chamber, the cave continues underwater through a series of submerged passages explored by cave divers. These underwater tunnels extend hundreds of meters beneath the town, and in recent years, divers have discovered entirely new sections of cave that were previously unknown. Each new discovery suggests the underground system may be far larger than early surveys indicated. Another major cave nearby is Tank Cave. Tank Cave is one of the longest horizontal cave systems in the region. Its passages follow fractures in the limestone that trend in consistent directions. These directions reflect the underlying stress patterns in the rock, essentially the way the crust cracked and fractured as it responded to tectonic forces. Water exploited those fractures, dissolving the rock and enlarging them into tunnels. So the shape of the cave network is not random, it's guided by the structural weaknesses already present in the limestone. One of the most dramatic features of the Mount Gambier karst landscape is the presence of sinkholes. A sinkhole forms when the roof of a cave collapses or when surface material slowly subsides into an underground void. Around Mount Gambier, sinkholes appear throughout the town and the surrounding farmland. Some have become famous tourist attractions, such as the Umperston sinkhole, which has been transformed into a sunken garden. Others remain water-filled pits connected to the cave system below. These sinkholes provide direct windows into the underground karst network, and they show just how close the cave system lies to the surface. One of the most fascinating aspects of the Mount Gambier cave system is its age. The limestone hosting the caves formed tens of millions of years ago. The caves themselves likely began forming sometime after the limestone was uplifted and exposed to rainfall, probably within the last 10 to 20 million years. But the volcanic eruptions that created Mount Gambier are only about 5,000 years old, so the caves beneath the volcano are vastly older than the volcano sitting above them. This creates an unusual geological layering of events. First, the sea laid down limestone, then groundwater carved caves through that limestone, and finally a volcano erupted through the landscape, leaving the cave system largely intact beneath it. Today, the Mount Gambier region is one of the most important cave diving sites in the world. The water in the flooded caves is exceptionally clear, allowing divers to explore submerged tunnels with remarkable visibility. Many of these caves remain only partially mapped. Every new dive has the potential to reveal additional passages extending deeper into the limestone, and because cave diving is technically demanding and potentially dangerous, exploration progresses slowly, which means the full size of the underground network remains a mystery. Standing on the surface of Mount Gambier today, it's easy to think of the volcano as the dominant feature of the landscape. The blue lake fills its crater, the volcanic slopes define the skyline. The eruption feels like the central geological story of the region, but beneath that volcano lies something older, an underground world carved slowly by water, hidden inside rock that formed in an ancient sea. A world of flooded tunnels, collapsed chambers, and sinkholes that open suddenly beneath the land. Most visitors to Mount Gambier never realise it, yet beneath the youngest volcano in Australia, the ground is hollow. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.